Lesson 8.6, it's just called some useful theorems. So basically what we're going to be doing is either writing polynomials or solving polynomials given the number of roots, and then using this idea of conjugate root theorem. So if you read the theorem here, it says if a polynomial with real coefficients has a plus bi as a root, then a minus bi must also be a root. We know this. When we solve quadratic equations and we get imaginary solutions, we get that they occur in conjugate pairs. The easiest way to explain that would maybe be using the quadratic formula. So if imaginary numbers occur when we have negatives under a square root, so according to the quadratic formula, we'll always have plus or minus that negative. So we can use this idea of the fact that they occur in conjugate pairs to then either write or solve polynomials. That's the game plan today. Okay, so the directions will read, find a cubic equation with integral coefficients that has the given numbers as roots. So this problem is telling us that x is negative 2 is one of the solutions and 5i is one of the solutions. Right away, using the conjugate root theorem, I know that if 5i is a root, then negative 5i is also a root. Again, you can just think of this as 0 plus 5i and 0 minus 5i. These are conjugate roots. So that's using the conjugate root theorem. I'll just write conjugate theorem to remind you. Okay, so we've done a problem like this earlier in 8.5. So if I know that x equals negative 2 is a root, then I know that the binomial x plus 2 is a factor of the polynomial. Because if you think about when you solve polynomial equations, you set each factor equal to 0. So setting x plus 2 equals to 0 gives me x is negative 2. So then I want to do the same thing with my other two roots. If 5i is a root, positive 5i, then x minus 5i is a factor. And if negative 5i is a root, then x plus 5i is a factor. So think about it. If I set this equal to 0, I would get the first root. If I set this equal to 0, I'd get the second root. And this equal to 0, I would get the third root. So now, just to get this cubic equation, we just need to go ahead and do all of the distribution. I might start by multiplying these conjugates together because it's going to be some pretty easy distribution here since we have opposite terms. X times x will be x squared. Like I was just trying to say here, the inner and outer are going to be opposites of each other, so those will just add to 0. 5ix and negative 5ix, I'm not even going to bother writing that down. But then if I multiply the last two together, 5 times negative 5 is negative 25. I times I is I squared. We know I squared is negative 1, which makes this x plus 25. Okay, let me just recopy the rest. We haven't done anything with this x plus 2 yet. But now let's go ahead and multiply these together. So x times x squared is x cubed. X times 25 is 25x. 2 times x squared is 2x squared. And then 2 times 25 is 50. We want to write this in standard form, so we want our degrees to be decreasing. So I'm just going to rewrite it like this. And there it is, a cubic equation that if we went back and solved it, would have the 3 roots that were given to us as a solution. All right, here's a very similar example. Find a cubic equation with integral coefficients that has the given numbers as roots. So x equals 5 and x equals 1 minus 2i. Same reminder for this one. Remember that imaginary roots appear in conjugate pairs. So if x minus I root 2 is a root, then x plus I root 2 is also a root. So we have 3 terms to work with here. Okay, so let's start with this first root, x equals 5. That means we have x minus 5 as one of our factors. Now, it wouldn't be that much fun to use these conjugate roots here as binomials, because I'm going to have like x minus 1 minus I root 2. So you could do it that way, but it looks a little sloppier. So if you remember back in chapter 7, we learned another quick little method for writing a quadratic given two roots like this. Remember, if we find the sum and the product, then we can write an equation x squared minus the sum times x and then plus the product. So that's what I'm going to do to get a quadratic for these two terms. So the sum of these two numbers is going to be 1 plus I root 2 plus 1 minus I root 2. So if I add those together, I'm just going to get 2. And then the product, these are conjugates, so 1 minus I root 2, 1 plus I root 2. We're going to get 1 times 1 is 1. Inner and outer terms will cancel, so then the last two terms will get negative I squared times 2, which I squared is negative 1. So putting that together, we just have 1 plus 2, or 3. So we have x squared minus 2x plus 3. So we can add that with our x minus 5. And then we only have to do a little bit more distribution to get our cubic equation. So we'll distribute the x to everything here. We'll get x cubed negative 2x squared plus 3x. And then distribute the negative 5 to everything. Negative 5x squared. I like to line up my like terms. Plus 10x minus 15. So putting that all together, our equation is x cubed minus 7x squared plus 13x minus 15 equals 0. Little bit different directions here. It says all but one of the equation's roots are given. Now we need to find the remaining root. So this says all but one, but that's already assuming that we know the conjugate root theorem, and we know that if I root 5 is a root, then negative I root 5 is also a root. So there's one more besides that, right? This is a cubic equation. It's degree 3, so we need to have 3 roots. So we're still missing one more. Okay, so here's what we want to do. Like the previous example, when we have these two roots, we can go ahead and do the sum and product rule to come up with at least a quadratic equation. So if I sum these, again, they're inverses of each other, so they'll just sum to 0. Product is going to be I root 5 negative I root 5. So that's negative I squared times 5, which is just 5. So I have the equation x squared minus 0x plus 5. Or if you just want to say x squared plus 5, same thing. So I know that this is essentially one of the factors, but there has to be some other x minus c to finish up that equation. Well, to find that x minus c, you've seen this before, maybe x minus c is ringing a bell. We can do synthetic division to find that last root. So let's figure it out. Let's take, let's see, where am I? This term here, x squared plus 5, and divide it out of this, right? If these two are being multiplied together, then if we just divide it out, we'll get what's left here. And we may have a coefficient of this this x as well. I'll just put a question mark there. So we'll find out when we divide that out. So let's take our polynomial, which is 2x cubed minus x squared plus 10x minus 5, divide what we came up with over here, x squared plus 5. So I'm going to go ahead and write it as x squared plus 5. You might want to write the minus 0x in there just so that you don't miss any terms, but it's up to you. Okay, so I say, all right, how many times does x squared go into 2x cubed? So I know I need to multiply by 2x. So multiplying that through gives me 2x cubed minus 10x. I'm going to line up my terms. Subtracting changes the signs, and I'm left with negative x squared. These positive, negative. Did I mess up my sign? Let me see. 5 and 2x, sorry, is 10x. So then we subtract, we change the signs. Those cancel. And I bring down my minus 5. So then I say, what do I have to multiply x squared by to get negative x squared? And that's just negative 1. And multiplying that through is going to end up giving me a remainder of 0. That makes sense, right? We're just trying to find the other factor of this polynomial. So coming back here then, here's the first part of the factor, so x squared plus 5. And then what's left is this up here, 2x minus 1. So 2x minus 1 equals 0. So the question says, find the remaining root. So to solve this, we'd set each piece equal to 0. Setting this first one equal to 0 is just going to give us right back the two roots that we already know. Right, so if I move the 5 over, negative 5, take the square root of both sides, I'm going to get x equals plus or minus I root 5. We know that. We already had that one. But we did all this work so that we could add 1 to both sides, divide by 2, that other remaining root. That's what this question was saying. Find the remaining root. The remaining root is 1/2. Let's do that again so you can see the process. So we're trying to find the remaining root. So we know it's a cubic equation, so we know we need to have 3 total roots. One's given to us, but we automatically know with the conjugate root theorem that 2 minus I root 3 is also a root. So we can do a quick sum product with this to write a quadratic equation. Summing them, again, they're conjugates. They're going to be 2 plus I root 3 plus 2 minus I root 3. So you'll get the 2 plus 2, oops, and the other terms are opposites, so you just get 4. And then for the product, we'll get 2 plus I root 3 times 2I minus root 3. Okay, 2 minus I root 3. So 2 times 2 is going to give me 4. Inner and outer terms will cancel. Then I'll get negative I squared times 3. So then we get negative 1 for I squared. So it's really 4 plus 3, or 7. So we have x squared minus 4x plus 7. So that's one of our factors. We're basically trying to figure out, well, what would be that other set of parentheses, that other binomial, to finish solving. And the way to get this is to use synthetic division. Or sorry, long division, not synthetic division. So we are going to do our original polynomial, which is x cubed minus 8x squared plus 23x minus 28 divided by x squared minus 4x plus 7. And I'm getting that right from here after we did the sum product. So let's do this division here. I know I need to multiply by x to get x cubed. Multiplying that through gives negative 4x squared plus 7x. When I subtract, all of these signs are going to flip. So x cubes cancel. That's what we wanted. Negative 4x squared. That's my handwriting. 23 minus 7x, we get 16x. And then we'll bring down the minus 28. So to get negative 4x squared, I need to multiply by negative 4. Multiplying that through gives me negative 4x squared plus 16x minus 28. Remainder of 0. That's what you should get if you did this right. So that means x minus 4 is what goes right there. So if we were to solve this equation, solving this first one, we don't really need to do it because it's already done. We could use the quadratic formula and get all the way back to finding our same two roots, which are x equals 2 plus or minus I root 3. But we already know those. The one that we care about is this one here. So if I set x minus 4 equal to 0, the one remaining root, which is what this question was asking for, is 4. Last one. All but one of the equation's roots are given. Find the remaining root. Okay, we know it's a cubic, so we know there has to be 3 roots. We're given x equals 3 and x equals negative 2i. So we just have to find one more. Hopefully you're smiling when you realize how to do this problem, because if you just use the conjugate root theorem, if you know negative 2i is a root, then positive 2i is also a root. Boom. There's 3. So nice, easy question. Look out for quick ones like that on the homework. So this was lesson 8.6. Go ahead and check Schoology for your assignment.